Hey everyone, let's talk about something that can absolutely kill even the most amazing AI application: speed. If you've ever built something incredible, only to watch it lag and frustrate people, then you know exactly what I'm talking about. Today we're going to dive into some powerful, practical ways to tear down those performance walls and make your applications fly.
Now, our source material makes this really bold promise: techniques to make your vector database 10x faster. Think about that for a second. That's not just a little tweak, right? A 10x improvement is a total game changer for how your users feel and how much your app can handle. So let's break down exactly how to get there.
So, does this sound familiar? You've built this amazing AI app, you're so proud of it, but when it's go time, it just hesitates. That little lag, that spinning wheel, it's more than just annoying, isn't it? It can undermine all your hard work. This performance wall is a super common problem, but it's one we can definitely break through.
Okay, so here's our game plan. First, we're going to figure out what's actually causing the slowdown. Then we'll hit the easy wins, the low-hanging fruit, with smarter queries and embeddings. After that, we'll get into the serious stuff and optimize the database core itself, get it ready for prime-time traffic, and finally, we'll wrap it all up with a simple action plan for you to get started.
First up, the race against latency. Before we can even think about speeding things up, we have to put on our detective hats. We've got to find the culprit, you know? You can't fix a problem if you don't know what it is.
So, who are the usual suspects here? Well, these performance killers, they often hide in plain sight. It could be that your queries are just taking forever to come back, or maybe generating embeddings is taking an eternity. It could even be a clunky index that's working way too hard, or your memory use is just going through the roof. Any one of these can just grind your app to a halt.
Okay, enough with the problems. Let's get to the solutions. This first section is all about smarter queries and embeddings. I want you to think of these as the big red levers you can pull for an instant speed boost. Seriously.
So the first big mental shift is this: stop doing things one at a time. Sequential queries? It's like having one single checkout line at a packed grocery store. It's just painful. The smart way, the fast way, you open up more lanes. Parallel queries let you handle a bunch of requests all at once, and it just slashes those wait times.
And this is literally how you do it in the code. You see this thread pool executor thing? Just think of it as hiring a team of cashiers instead of just one. Your code becomes the manager, handing out tasks to all the cashiers at the same time. It looks simple, but the performance jump is just massive.
All right, next up, let's take that same idea. Don't do it one by one, and apply it to generating embeddings. Making a separate API call for every single piece of text, that's just crazy inefficient. It's like sending one delivery truck for one package, then another truck for the next package, and so on for 100 packages. No way. The fast way is batching. You put all 100 packages on one truck and make one single trip. It's just common sense, right?
And here's the code that pulls it off. See that batch size? You're basically just telling the code, hey, group these texts into batches of 100 before you send them off. Instead of 100 separate requests, you make one. This one little change can seriously make your embedding process up to 10 times faster. 10 times!
Okay, so we've sorted out our queries and embeddings. Now it's time to go deeper, right into the engine room of the vector database itself. We're talking about efficient indexing and data. This is where we start really fine-tuning things for maximum performance.
All right, this next technique is a really cool one. It's called quantization. The best way to think about it is like compressing a giant photo into a smaller JPEG. The file gets way smaller, but you can barely tell the difference in quality. Quantization does exactly that for your vectors. It shrinks them down, which can cut your memory usage by something like 4x, with almost no hit to your accuracy. It's kind of magic.
And you know what the best part is? Look how easy this is. In a database like Qdrant, it can be just a single line in your config. You're just telling it, hey, use these smaller, more efficient numbers instead of the big, chunky ones. That's it. One line of code for a 4x memory saving? I mean, that's an incredible deal.
Okay, another pro tip: put your vector index on a diet. Seriously, don't load it up with tons of heavy data like the full text of documents. That just slows it down. Your vector database only needs two things to do its job: the vector itself and a simple ID to go with it. Keep all the other heavy stuff somewhere else, somewhere cheaper, and only go get it when you actually need it. This keeps your index super lean and super fast.
So, our app is fast for one person. Awesome. But what happens when thousands of people start using it at once? That's what this next section is all about: scaling for production. We're getting ready for prime time.
One of the most powerful ways to scale is using what's called a read replica. Check out this line of code here. Just by setting replicas equals 3, you can literally triple your capacity to handle searches. What it does is create identical copies of your index, so when all those search requests start flooding in, they get spread out across the copies. It's like opening more toll booths on a busy highway. No more traffic jams.
But of course, how do we know any of this is actually working? We can't just guess. You have to measure. This little function right here, benchmark optimization, is going to be your new best friend. It just runs your search over and over, times it, and tells you the average speed. You have to, absolutely have to, benchmark before and after you make a change. Otherwise, you're just flying blind.
So let's look at the results. Here's a pretty typical before picture. An average search time of about 482 milliseconds. Now that might not sound like a lot, but trust me, your users feel that delay. This is our starting point.
And now, here's the after. By putting all these techniques into practice, that latency just plummets all the way down to 45 milliseconds. That's not a 10% improvement, that is a 10 times improvement. It completely changes the feel of the app from sluggish to, well, instant. This is what we're aiming for, and it is totally achievable.
Whew, okay, we've gone through a lot. So let's bring it all together in this final section, your first optimization. It's time to stop talking and start doing.
The source material lays out a super simple 3-step plan. Step 1, profile. Find out what's actually slow. Don't guess, use data. Step 2, apply. Pick just one of the things we talked about and implement it. And step 3, measure. Run your benchmark and see what happened. That's the loop. Profile, apply, measure. Simple.
So what does a win actually look like? It's really important to remember this. It's not just about speed. Success is getting that big performance boost without messing up your accuracy. I mean, a super fast search that gives you garbage results is useless, right? The goal is to be fast and smart.
And that's pretty much a wrap. We've looked at the common problems, we've walked through the fixes, and we've seen just how dramatic the results can be. The only thing left to do is for you to try it. So I'll leave you with this question. When you look at your own app, which bottleneck are you going to tackle first?